Is it? Yes, it's going. Okay, sweet. Okay, so we just did a lab, all right, about kinetic energy. And who knows what you know everything about physics, Connor? What's kinetic energy?
It's when things move.
That is good. That is very true. Wait, so what's everybody? You're math then?
Yes.
And you are. I want to say you're Russian because you know Russian, but that's not true. What are you studying?
Not even close. Computer science.
Computer science. Okay, cool. And then
Applied math.
applied math. Cool. So we all have math people in here. That's great. Okay, sweet. So yeah, so kinetic energy is the energy of things as they're moving. Shocker. So our lab that we just did is we had all three of you were on a team, right? And someone had a radar gun, and somebody had a ball, and someone was recording stuff. Because that's a boring job, but it's has to be done. Okay.
There's
Yes. So somebody threw the ball as hard as they possibly could, and you measured how fast it was going. Okay? And we measured the mass of the ball to be 5 grams. That's 10 grams. No, that's
still pretty small.
15. It's 15 grams. Okay. So the ball is 15 grams. Okay? And you measured the velocity. You measured it 3 times. All right. So you may want to write these down for these velocities. Okay? So the first velocity. Oh, I'm sorry. I have some. Yes. Oh. Oh, sweet. I have markers. It's more fun. Bright pink? No? Okay. All right. That's probably better. Okay. Just think of the gold as you're doing this. This is worth it. Worth it. Okay. I appreciated your clarification.
Wait, did you promise her gold too?
I did. You have to split it.
Yeah.
Or maybe is it the first gold mine I discover goes to Connor and then no, you commented first. You get the first gold mine.
Oh.
For sure. Yes. That's fabulous. And then or maybe we should
just split it.
Okay.
Because what if you don't find 2 gold mines?
Are you doubting my 30-acre Texas
How
farm?
much gold is there in Texas?
So much gold in Texas.
Really though?
Maybe I'm thinking of oil.
The black gold? Yeah, I'm pretty sure that's what you're thinking of.
First valuable thing I find on my ranch.
You said it was specifically gold,
That is true. If you would rather have gold, I can wait until I find the gold, and I will keep all the millions of dollars of oil to myself.
Okay, alright. I'll accept this change.
Okay, so the first velocity of the ball was Ashley, and she was feeling super strong, and she did 15,000 centimeters per second. Alright? Was the first velocity. And then Connor was still feeling pretty strong, and he did 10,000 centimeters per second. And then Rachel, I'm sorry, you were having a bad day. You must have been sick or something.
Accurate.
You got it. You were going 10 centimeters per second.
Oh, wow.
I don't know how you do that. It was
That's impressive.
That is
It's like
very
impressively
impressive.
slow.
That's good. Okay, so does anybody know the equation that we use to calculate kinetic energy?
mv squared.
Excellent, exactly. So 1/2 mv squared. So everybody take 30 seconds and try and figure out what the kinetic energy was of the ball that actually threw.
Hold up, just to check.
Yeah, go.
Is it supposed to be grams or kilograms?
Excellent question. Which one is the unit that we use in
For
physics?
I'm gonna go with kilograms.
It is
That
in
seems-
kilograms. So
okay.
how would you switch 15 grams to kilograms?
Do something like
Yes, you do something. It's good. Yes. Okay.
that one would be that.
And give me a thumbs up once you have it. Oh, I'm sorry. I should have provided calculators. I have a phone and a calculator.
Just look it up on the internet.
That's a good point.
something-
Talk to your neighbor.
Some sort of unit.
That's good. Okay, discuss among yourselves what you think the answer should be, including the units.
Okay, so I got 1.125 units.
I'm still in kilograms centimeters.
Wait, are we doing
So I
these
need
for
to
each
figure this out.
velocity?
So just for the first one. For now.
Oh, just the first
Yes.
one. Okay, that explains. Okay, 1 sec.
You go, girl. That's awesome. But if you
Wait.
manage to get all three done, that would be really good.
Yeah, what should, is it meters?
So it should be
yeah, I think
that's
it's
the
meters.
that's the like
Meters.
standard.
Okay.
But I don't know. I don't remember what that unit
I think it's
creates.
joules, but I'm not sure.
Wait, so what are we trying to calculate right now?
The kinetic energy.
So I
Energy.
guess joules.
That is correct.
Okay, cool.
Energy unit is joules. Nice. Are you guys giving the same number?
What number did you get?
I got 1.125.
Okay, let me redo this.
Then yeah, I might need to
I might have done something
You
wrong.
might have. You might have.
Oh shoot! I didn't square that. Oh.
Glad we
Yikes. Yeah. This is what happens when I try to make shortcuts. Alright. This number
There we
seems-
go.
Okay, that's
Yeah,
what
I
I
was
got.
gonna say that is remarkably low energy for such a
Okay.
powerful
I think I
throw
didn't
that Ashley
convert
gave
it
us.
right. Let's do centimeters.
I forgot to square it.
There you go. So hey, Rachel, can you show us step by step what did you do to get the answer for this one?
Okay, well, first I divided the 15 grams by 1,000.
Why did you do that?
To convert it to kilograms.
Fabulous.
And then I divided the 15,000 centimeters per second by 1,000, and then I realized that was wrong, and then I divided by 100 instead.
Perfect.
And
This
then
is good scientific process. This is
Yeah.
fabulous.
So then I took that, and that was 150, and I squared it, and I multiplied it by 0.015 for the mass, and then I divided it by 2.
Woot woot. All right. Everybody get the same? Okay, cool. So now we're gonna try to do the second one, but you're gonna have 30 seconds. On your mark, get set, go. Hey, you. You're totally fine. If you, I need at least 3. So if you want to come in, you're welcome. You guys got it? That was like
Did
under
we all
20
get the
seconds,
same
guys.
Yeah, we did.
What'd you get? What'd you get?
75.
So if you want to come in, you are welcome to come. But if you have other things to do, don't feel guilty. All right, good job. Okay, this time do the next one in under 15. Ready, set, go.
Whoa.
Small move.
That's a
Time.
small number.
Okay, what did we
Did
get for
everyone
that
get
last
the same
one?
small number as I got?
Yes.
Oh,
Yeah.
Rachel, that's a
Yes.
sad amount of
That's
energy.
really
That is actually really impressive. Maybe that's your superpower. You can
Yeah.
throw things
Throw
in
things
very
extremely
slow motion.
slowly.
Epic. Good job. Okay, all right. Nice work, everybody. Okay, so we are going to try another scenario now. Are you ready? Okay. So once upon a time, we have a young man named Jimmy. All right? Now, Jimmy is racing down this hill super, super fast in his race car. All right? Jimmy is 50 kilograms. I'm going to write that down so I don't forget. Okay. Jimmy is 50 kilograms, and his race car is 3,000 kilograms. All right? Now, at the very bottom of the hill, his kinetic energy is 500,000 joules. How fast is he going?
What was that last number again?
Bless you. 500,000. So his kinetic energy is 500,000 joules. How fast?
Oh, that's not right. It's a really heavy race car.
It's working on its way, okay? Maybe it's made of uranium. that has other problems, but hope they don't crash. Oh dear. Oh, sweet. Would you like to use the calculator?
My calculator's fine.
Would you take some
Obviously.
deep breaths?
Square root.
Yeah, it got rid of my. I had the answer and then I tried to square root it. That doesn't seem right. Okay. Yeah. Never mind.
Oh,
Yay.
nice!
I had the number and then I tried to square root it and it just got rid of it and I'm like, that is definitely not what I
Ready?
wanted.
Okay, Ashley, walk us through it. How did you get that?
So I just used our equation again. Kinetic energy equals 1/2 mv squared. So I multiplied by 2 and I divided by the added mass and square rooted it because I wanted velocity by itself.
Fabulous. And plug it all in. Nicely done, everybody. That is fabulous. Okay, so 18 meters per second is pretty fast. But it's surprising to me. I just made these numbers out of my head, right? But 500,000 joules, about how much? Like, is that a lot? Or is that
It seems like a lot, but
a fair amount, right? It's interesting. So why do you think, if we have so much energy, why aren't we going faster?
18 meters a second is pretty dang fast.
Pretty
though.
fast, but for 500,000 joules?
I guess the race car.
That
weighs
to
so
me
much.
seems reasonable, but
Say that one more time.
The race car weighs too much. Well, a
The
lot.
race car weighs a lot, and it kind of counteracts what the velocity would be. Because if my mass goes higher, if I keep my energy constant, what has to change? If my mass is going up,
oh, the
and this
velocity.
is velocity has to go down.
I like it.
That's
Yeah,
light is so
exponentially.
fast.
What's that?
That's why light is so fast.
Yeah, it is. That's actually a really insightful point, Carol. Would you care to explain that?
Oh, light has no mass, and it's like the fastest thing in the universe.
I actually never thought of it that way. That's perfect. That's so true. It is super high energy. As the mass goes down, the velocity goes up. My brain just exploded. Thank you. What a beautiful thing. Okay, fabulous. Well, does anybody have any questions about kinetic energy? Or how we calculate it? Or why? Or what it's used for? Okay, well, let's just review one thing from last class since we have a couple more minutes. Who can remember other kinds of energy that we have? There's kinetic is a possibility. What's another one? Potential. Good. Good. There's a lot of potential kinds.
Yeah.
Does anybody know any specific?
The potential like
That's good.
Oh, okay.
Potential
Elastic.
kinetic. So there's only kinetic
Okay.
because that's when potential expresses itself. So it's like kind of the opposite of the potential. So there's gravitational. That's good.
Elastic.
Elastic. So what might be an example of gravitational potential?
if you're on a cliff.
Huh?
If you're on a cliff.
If you're on a cliff.
Yeah.
Why do you have gravitational potential if you're on a cliff? That was exactly right. Thank you, Connor. Fabulous. Yeah, good. Good. So does my pen have gravitational potential energy right now?
It's
Technically,
close.
it's
Well,
zero.
I mean,
It's zero.
yes and no.
Please elaborate.
Well, because it would require the building coming down
Yeah.
in order for to do anything. So
Pick
It's
me.
true. It's true. Yeah, Carol.
It does have gravitational potential energy. It's just zero.
There you go. See, it all is in a frame of reference, right? So if I am saying that the ground is zero,
okay.
like if I'm measuring from the ground, does this have any potential energy? No. What if I'm measuring from the ground now? Does it have potential energy? What if I'm measuring from this line? Does it have any gravitational potential? No. It's all perspective.
It's all relative.
Yeah. It's amazing. Okay, cool. Well, y'all are fabulous. Thank you so much for humoring me with this. Nicely done.
fun.
You're all brilliant.
Wait,
So
I
brilliant.
thought this was a real class.
Yes, you are all graduated from